Okay. So before going for the problems, I'll just repeat it again. What is Venturimeter? Because this is an important part of important question from the exam point of view also. So Venturimeter is a device which we are using to measure the discharge or rate of flow of fluid through the pipes. Okay, we are measuring the Q using the Venturimeter. So we are connecting a Venturimeter to a pipe. You can see this blue color is a pipe. Okay, we are connecting a Venturimeter to the pipe and we are determining the flow rate which is flowing through the pipes. Okay, fine. So this venturimeter is made up of three parts. One is converging part, throat, and diverging part. So we are getting the pressure difference between the inlet of the pipe and the throat. Okay. So to measure the pressure difference between the inlet and the throat, we are using this venturimeter. Okay. This will give, as I have told you yesterday, there is whenever the fluid is flowing through the pipe, if you want to measure the pressure of the pipe, what we are doing, we are connecting something called as a piezometer or a U2 manometer or anything, differential manometer, everything. So when the fluid is flowing, it will try to push the liquid inside this tube and it will rise. So this rise H is given by P equal to rho GH. Okay. By using this method, we can determine the pressure. The same way, the pressure will be increasing in this. Okay. High head will be, sorry, the H will be increasing in this. Okay. So depending on this H is nothing but what height of the fluid raised in that tube. Okay. Okay, fine. Now what happens is, if you want to measure the pressure, how you will measure? P equal to rho GH. Okay. Now, H is what? This one. H1, H2. P1 by P1 rho G1, rho G H1. Okay. Then P2 rho G H2. Okay. So that's why I have written a equation that P1 by rho G equal to H1, P2 by rho G equal to H2. This one will be H1 minus H2 something equal to H. So that is the difference which we are taking in a venturimeter. Okay. So remember that these are useful for your practical purposes. Okay. So it has three parts I have told you. One is convergent section, another one is throat, and another one is divergent part. Okay. What happens is whenever the fluid comes here inside this pipe, it will be having some pressure and some velocity. So with that pressure, it will rise here. The pressure will be more here. Okay. When it comes through the converging part, what will happen? The pressure will reduce. Okay. As I have told you in a nozzle, what happens? The pressure will reduce and the velocity will increase. So after this converging part, there will be a throat section. So the fluid has to flow through this. So it will be at lower pressure. So it will rise like this. It will rise to a point. So difference between these 2 points is H. Difference between these 2 points is H. Okay. So that we are going to determine in venturimeter. Using that, we are going to determine the discharge which is flowing through the pipe. Okay. There is one more confusion while solving the problem. We'll discuss that. So this is the derivation which we have done yesterday. So what we have done is we have taken consider a horizontal pipe to which we have connected a venturimeter like this. Okay. And I told you the fluid will be flowing through this pipe and the water will be rising in this pipe, and another fluid will be flowing through the throat, the water will be rising in this. So this difference in between these two is known as H. Okay. So the fluid, the pipe diameter is D1. The throat diameter we can take as D2 because it is at section 2. Okay. Now, so let D1 is the diameter at inlet at section 1, P1 is the pressure at section 1, velocity of the fluid at section 1, E1 is area of this area at section 1, that is pi by 4 D1 square. Same way, if we go for the section 2, D2, P2, V2, E2 are the values at section 2. So to get this, we are going for applying Bernoulli's equation. We have told you Bernoulli's equation is P by rho G, V1 square by 2G plus Z1. So Bernoulli's equation is obtained from the Euler's equation, and Bernoulli's theorem states that it is the total energy is equal to the sum of pressure head, that is P by rho G, plus sum of pressure head, velocity head, V square by 2G, and datum head, Z. Okay. So if we are considering two sections, then it will be like this. Okay. Now as the pipe is horizontal in this, as the pipe is horizontal here, therefore Z1 is equal to Z2. I have told you, if I keep the pipe vertical, okay, then what will happen? Z1 and Z2 will not be same. Okay. But here, as the pipe is horizontal, Z1 equal to Z2. If it is Z1 equal to Z2, then what will happen? This and this will get cancelled. So remaining will be P1 by rho g plus V1 square by 2g equal to P2 by rho g plus V2 square by 2g. Now, to get an equation, we have to write it like this. We have written C. P1 by rho g plus V1 square by 2g and everything. So we have to just interchange. So P1 by rho g minus P2 by rho g equal to V2 square by 2g minus V1 square by 2g. This will be the equation which we are getting. Okay, I can write this P1 minus P2 by rho g. Difference in the pressure head as H. Difference in the pressure head as H. You can see here. Difference in the pressure head as H. See, this height, rising height is called, I'll say it is H1. Okay, this rising height I'll call as H2. Okay, so this H1 is nothing but P1 by rho g. Do you agree with the equation which I have told you previously? Hydrostatic law. H2 is P2 by rho g. Okay, so that difference is nothing but H. Therefore, P1 minus P2 by rho g is H. Difference in the pressure heads. Remember this point. Okay, there's one more term which is going to come now in the problems, and you already solved it in the previous problems of Bernoulli's equation. Okay, so now P1 minus P2 by rho g equal to V2 square minus 2g minus V1 square by 2g. But this P1 minus P2 by rho g is the difference of pressure heads at section 1 and 2, which is equal to H. As I told you in the previous slide, it is equal to H. Or we can write like P1 minus P2 by rho g equal to H. By substituting this P1 minus P2 by rho g in the above equation, that is in this equation, I'm going to substitute H here in terms of P1 minus P2 by rho g. So H equal to V2 square by 2g minus V1 square by 2g. This is our equation 1. Okay. Now we apply the continuity equation, because we have both the unknowns. Okay, V2 and V1. So we are getting it to only one term, that is A1 V1 equal to A2 V2, V1 equal to A2 V2 divided by A1. So whatever value is there here, V1, I'm going to substitute A2 V2 by A1, so that this V2, so that we can get two V2s over here. Okay, V2 square by 2g and somewhat minus this completely A2 V2 divided by A1 divided by 2g, this whole square. Okay, so we have got like this. So we have got two V2s. Okay, so it is to simplify the expression. Okay, so we have done like this: A2 V2 square divided by A1 by 2g. Okay, so what is V2 square by 2g? 1 minus A2 square by A1 square. If you take V2 square by 2g as common, what will remain? 1 minus A2 by A1 whole square. Okay, then H equal to what? V2 square by 2g, A1 square here minus A2 square divided by whole A1 square. Okay, then I want in terms of V2, because I want to calculate the discharge now. I want to calculate the discharge. Q equal to A2 V2. I want to calculate the discharge. So V2 square equal to 2gh into A1 square divided by A1 square minus A2 square. So V2 equal to square root of 2gh, and we are getting A1 by square root of A1 square minus A2 square. Why? Because this square root and this square will get cancelled. Therefore, it will be A1 square root of A1 square minus A2 square into square root of 2gh. Okay, this is our V2. Now you have to just substitute in the equation Q equal to A2 into V2. So A2 into this whole equation. So remaining equation we have seen yesterday what it will be. So I have to just substitute A2 V2 in this equation. Then we are getting A2 into A1 divided by square root of A1 square minus A2 square into square root of 2gh. Then the final equation will be A1 A2 square root of A1 square minus A2 square into square root of 2gh. Now, I have told you that this is a theoretical equation. Okay, theoretical equation. Here, the discharge will be maximum. Okay, more compared to the actual discharge. Okay, so equation 2 gives the discharge through the ideal conditions and is called the theoretical discharge here. Actual discharge will be less than the theoretical discharge. Therefore, Q actual, how to find out this Q actual? I have told you there is one term called as coefficient of discharge. CD equal to Q actual by Q theoretical. It is the ratio of Q actual by Q theoretical. I have Q theoretical. Okay, I have Q theoretical. So I'll be multiplying Q actual by equal to CD. Q actual equal to CD into Q theoretical. So this is Q theoretical, and whatever value we are getting this Q theoretical, we are multiplying it with CD. So if you multiply it with CD, it means that it is actual velocity, actual discharge. Okay. So this CD coefficient discharge should be less than 1. So as I have told you yesterday, the value should be between 0.96 to 0.99. Okay, 0.96 to 0.99. So this should be the value of coefficient of discharge. Okay, fine. So this is the derivation for rate of flow of discharge through Venturimeter. This is also an important question. The important questions were the Bernoulli's equation, derivation, Euler's equation, from the beginning of Euler's equation to end of Bernoulli's equation, its statement, its assumptions, okay, and limitations. Okay, then we go for the problems. Problems are important, also important from the Bernoulli's equation also, and from Venturimeter also. Okay. And this derivation is also important, Venturimeter derivation. Okay, derive an expression for rate of flow through Venturimeter. Okay. They may write volumetric rate of flow, or they may write flow rate, they may write rate of flow, they may write discharge also. Anything it may be, but you should remember that rate of flow or discharge or volumetric flow rate are same. Okay, or flow rate. Fine. The next is value of H. So as I've told you, H is what? The difference in the pressure head. H is what? Difference in the pressure head. What is the expression for real fluid? Bernoulli's equation for real fluid. Anyone? P1 by rho g, V1 square by 2g plus Z1 equal to P2 by rho g plus V2 square by 2g plus Z2 plus HL. This is the head loss. Okay, don't get confused with this H. Remember this, it will help, it will be confused in problems. Okay, don't get confused with this H is the pressure difference head, difference in pressure heads, and this H is the loss of head. Okay, fine. So we have studied that loss of head is equal to 0.3 times of the velocity difference of velocity head, 20% of difference of velocity head, like that. Velocity head kya hai? V1 square by 2g minus V2 square by 2g, or opposite of that. Okay, vice versa. Fine. So you don't get confused with this H. So the value of H will be different for different cases. So as I've told you, if now we are considering a pipe which is horizontal, we're considering pipe which is horizontal. We're considering pipe which is horizontal. Here we are saying that let the differential manometer contains a liquid which is heavier than liquid flowing through the pipe. I am connecting a differential manometer to this pipe, okay, to which a manometer Venturimeter is connected up, okay, or not connected, whatever it is. Okay, so let the differential manometer contains a liquid which is heavier than the liquid flowing through the pipe. So a differential manometer is connected in which a heavier liquid is there, which is heavier compared to the liquid which is flowing through the pipe. Okay, which is heavier liquid to मतलब यहाँ पे mercury है और यहाँ पे पानी है, water. Okay, if there is mercury over here and there is water over here, this is that example. It is not like same always. Okay, like we can take an oil which is having less specific gravity compared to the mercury. Okay, like this. So what is the formula for H? What is the formula for H? That is, any doubts? Please mute yourself. Rajat. Okay. Fine. The value of H is given, H equal to X, H by S naught. If there is a lighter liquid in the fluid which is flowing through the pipe, and differential manometer, if there is a lighter liquid in the differential manometer, and if there is a fluid which is having more specific gravity compared to the differential manometer, then the equation will be like this. Same way for the previous one. Okay, how it will be? H equal to P1 by rho G plus Z1 if it is an inclined Venturimeter. If it is an inclined Venturimeter with U-tube differential manometer. Okay. That previously we have seen that H equal to P1 by rho G minus P2 by rho G, because Z1 is equal to Z2 because the pipe was horizontal. But here if it is an inclined Venturimeter, then what happens is P1 by rho G plus Z1 minus P2 by rho G plus Z1. Z2, sorry. So that will be related. It is the same way. Previous one, how it was in previous one, how it was that there was a heavier liquid in the differential U2 manometer, and the fluid flowing through the pipe is lighter liquid. So in this way, the equation will be there. Next, for inclined venturimeter, when a liquid is lighter than the liquid which is flowing through the pipe. In differential manometer, we are having a lighter liquid compared to the liquid which is flowing through the pipe. Then the equation will be like this. Okay, there's no much difference in the previous equation and this equation. H ka value same rahega. But what happens is P1 by rho G minus P2 by rho G value it is. Remember this, huh? This is P1 by rho G minus P2 by rho G equal to H. This is this expression. But here what happens? The next equation, I am taking this equation here because Z1 and Z2 won't be equal to each other. Therefore, Z1 and Z2 are taken separately. Therefore, the equation will be like this. Okay. So next is problems. We have seen some problems. Okay. Now we'll solve another problem. Did anyone get the answers correct for this? Did you solve this? Okay, you might have got. So next problem has to be solved by you people. So please write down the problem. The question is like this. A 30 centimeter and 15 centimeter Venturimeter is provided in a vertical pipe. So here vertical pipe we are using. Carrying a oil of specific gravity 0.9. In a Venturimeter there is a liquid which is flowing through that is an oil which is having a specific gravity of 0.9, and the flow is being upwards. The difference in elevation of the throat section and the entrance section of the Venturimeter is 30 centimeter. Therefore, Z1 minus Z2 is 30 centimeter. Throat section, difference in the elevation of throat section and the entrance section. Z2 minus Z1 or Z1 minus Z2 is 30 centimeter. The differential U2 mercury manometer shows a gauge deflection of 25 centimeter. Therefore, there is a deflection of mercury manometer, na? So that is 25 centimeter. Calculate the discharge of oil through the pipe, the pressure of difference between the entrance section and the throat section. Then take the coefficient of discharge as 0.98 and the specific gravity of mercury as 13.6. So there is a vertical Venturimeter which is placed here. Okay, the distance between or the elevation between the section 1 and section 2 is 30 centimeter. The deflection in the pipe in the U2 manometer is 25 centimeter. Okay, this. So I have told you the pressure, we are going to measure the pressure difference, na, H. So this is H, the difference in pressure head. Okay. We have to determine the discharge of oil which is flowing through this pipe, and the flow is moving upwards. Okay. The specific gravity of the mercury is given as 13.6, and the specific gravity of the fluid which is flowing through the pipe is 0.9. What is this 30 centimeter into 15 centimeter Venturimeter? Anyone? What is that 30 centimeter and 15 centimeter? Can anyone tell me? What is 30 centimeter, 15 centimeter Venturi meter? What it suggests? D1 is 30 centimeter and D2 is 15 centimeter. Which is this D1? Which diameter it is? Which diameter it is?
Convergent.
Convergent. It is the diameter of the pipe. I've told you we are measuring the pressure difference between the diameter of the pipe at the inlet into the venturimeter and the throat. So it is the diameter of the pipe, and 15 centimeter is the diameter of the throat. Convergent part C, what happens is we are connecting this convergent part to the diameter, oh sorry, at the inlet of the pipe. Okay, at the inlet of the pipe, we are connecting it, right? So this is showing, this one is the inlet, okay, and two is the throat. Inlet of the pipe to the venturimeter. Okay, now diameter inlet is 30 centimeter, 0.3 meter. What will be the area? 0.0706. What is diameter at throat? D2. What will be the area for this? Anyone? A2? How will you calculate A2? How will you calculate A2?
Pi by 4.
Pi by 4 d square. Calculate and let me know.
0.0176.
0.0176 meter square. Okay. We are considering section 1 as represents the inlet of the pipe and section 2 as throat of the pipe. Remember this is not the converging part. Section 1 is the inlet of the pipe, and this pipe, there is a pipe. If you consider there is a pipe, okay, there is a pipe. I want to measure its flow rate. So what I'll do, I'll connect a venturimeter to this. So venturimeter will be like this. Okay, imagine like this it will be, and इस side फिर से pipe आ जाएगा. Okay, understood. So what will happen? I want to measure the pressure difference at the inlet and at the throat. So this will be section 1, this will be section 2, like this. Okay. Now Z2 minus Z1 is 30 centimeter. How we got this is, see what you have written is question in the question. See the difference in the elevation of the throat section, that is Z2, and the entrance section, that is 1, Z1 is 30 centimeters. Therefore Z2 minus Z1 is 30 centimeters, are given by 0.3 meter. Now specific gravity of the fluid which is flowing through the venturimeter is what? Specific gravity 0.9. Okay, specific gravity of mercury is given as 13.6. What is the reading of differential manometer? This is H, 25 centimeter. Okay, done. Now how you will calculate the discharge of oil? What all you require here? I want to calculate first discharge of oil. I've written everything which is given over here in the problem. How will you calculate the discharge of oil? Anyone? Anyone?
We derive the expression, no?
Which we will derive the expression here.
That Q actual.
Q actual expression. Okay, Q actual से हमको first we have to use Q actual. What is the equation for Q actual? CD A1 A2 divided by square root of A1 square minus A2 square into square root of 2GH. Okay. My question is that we have A1, we have A2, we have A1 and we have A2. Okay. Square root of 2GH. Okay. Now, so we want the value of H, na? We want the value of H or no? See here. Here we want the value of H, right? We don't have the value of H. H is what? This is a vertical Venturimeter. Okay, it has Z1 and Z2, and the liquid which is flowing through the pipe is lighter compared to the liquid which is flowing through the which is there in the differential manometer, because the specific gravity of mercury is more compared to the liquid flowing through the pipe. Okay, so we have to use which example? This one, because why I have taken Z1 and Z2 here? Because both are having some difference. Both are not equal. It is vertical. Okay, then we are using this equation. Why? Because there is a heavier liquid in the venturimeter, sorry, in the manometer, and there's a lighter liquid which is flowing to the venturimeter. Can you calculate and let me know the answer here? What will be the value for H? What will be the value for H? What will be the value for H? So H equal to P1 by rho g, you can take this as Z1 minus Z2, Z2 minus Z1 30 centimeter, and X is how much? 25 centimeter, that is 0.25. Sg is 13.6 divided by 0.87, 0.9, 13.6 divided by 0.9 minus 1. So 0.25, 13.6 divided by 0.9 minus 1. So what is the answer for this? You calculate this part first.
3.52.
How much?
3.52.
3.53. I got 3.53 meter of oil. H is this much. Now, the discharge of oil is given by this expression. Now, you have got all the values. You have got CD 0.98. You have area A1 and A2. You have A1 square minus A2 square, and you have H value. Okay, substitute and tell me the answer for Q actual. Substitute the value of CD as 0.98, area A1 and A2 you have found out, into square root of 2G 3.53. Tell me the answer for Q actual.
0.148.
0.148 meter cube per second. Okay, so the in terms of liter per second, it will be 148.80 liters per second. This is your answer for discharge of oil. First is done. Second, what is the what you have to find out? You have to find out the pressure difference between the entrance section and the throat section. How you will find the pressure difference? Pressure difference is P1 minus P2. The entrance P1 minus P2 you have to find out. Okay. So this is the pressure difference between entrance and throat section. This is the formula, right? So you have to find out P1 minus P2. This is H, which we have calculated previously. Then P1 by rho g minus P2 by rho g equal to Z1 minus Z2. I have separated the equation. So that is equal to 3.53 meter of oil. Can using this, can we calculate the value of P1 minus P2 by rho g? P1 minus P2 difference in pressure. Can anyone calculate and tell me the answer for this? What is the value of P1 minus P2 difference? Fast. What is the answer for P1 minus P2? See here. What is Z1 minus Z2? Z2 minus Z1 is 0.3 meter, right? So Z1 minus Z2 will be minus 0.3 meter. Okay, so P1 by rho g minus P2 by rho g. Okay, I'll take this as minus 0.3 meter. Okay, now equal to 3.53. Okay, so it will be 3.53 minus 0.3, sorry, plus 0.3. Plus 0.3. I'm taking this side here. So this whatever answer is there, it will be equal to P1 minus P2 by rho g something. Therefore, P1 minus P2 equal to whatever answer you have got here multiplied by density. What is the density of oil here? What is the density of oil? 0.9 specific gravity, 900 into 9.81. So P1 minus P2 will be answer of this. Can anyone tell me the answer?
Thirty-three point 81.
30?
33.81.
Okay, we'll see here. So Z2 minus Z1 is 30 centimeter, that is equal to 0.3 meter. So P1 by rho g minus P2 by rho g equal to minus 0.3 equal to 3.53. Correct? This is correct now. So I got P1 by rho g minus P2 by rho g. If I take this here, it will be addition. Okay, sorry, it will be addition plus 0.3. That will be 3.83 meter of oil. Then what happens? P1 minus P2 equal to, I've taken this rho g here because both are common same, numerator denominator is same. Therefore, P1 minus P2 by rho g. So this rho g I have taken here. Rho is, how you calculate, this is rho of oil, whatever fluid flowing through the pipe, not the density of, not the density of mercury. It is density of oil, 900 into 9.81. So we have got 33,815.07 Newton per meter square. Is this answer correct?
Yes, sir.
Okay, fine. Next. So in terms of Newton per centimeter square, that is 3.38 Newton per centimeter square. So we have calculated the difference in pressure and the discharge. So the next problem. This is an easy problem. I want everyone to solve this. An oil of specific gravity 0.8 is flowing through the Venturi meter. The oil is flowing through the Venturi meter. Okay. Having an inlet diameter 20 centimeter and throat diameter as 10 centimeter. D1 is 20, D2 is 10 centimeter. The oil mercury differential manometer shows a reading of 25 centimeter. This oil mercury differential manometer reading is nothing but what? 25 centimeter. Calculate the discharge of oil through the horizontal venturimeter. We have to calculate the discharge of oil which is flowing through the horizontal venturimeter. Specific gravity of oil is given. Specific gravity of mercury is given. Reading of differential meter X is 25 centimeter. Difference of pressure head, that is H equal to X SH by S naught minus 1. Okay, so that is the value where we are using this X in to calculate the difference of pressure head. Can anyone calculate and let me know the answer? What is X here? What is X here? 25 centimeter. SH is 13.6 divided by 0.8. Now one thing is that if everything is given in centimeter, you can keep in centimeter. Okay, don't think you can change also, or you can keep it in centimeter and solve the problem. Okay, in some books what they have done, they have kept it as centimeter only and they have solved the problems. Okay, but if you want, you can convert it into meter and solve them. Then later on, when you're converting that pressure or whatever discharge is there, you have to convert it into meter cube per second or liter per second. Okay, so this is the thing. So one problem I had, I think I have done like this only. I have taken centimeter as the unit because everything is in terms of unit centimeter. Okay, so H equal to X 25 divided into SH is how much? 13.6 divided by 0.8. So we have got this much. 25 into 13.6 divided by 0.8 minus 1. How much is the answer for this?
400.
400 centimeter of oil. See, I have not converted the unit. Don't get confused. You can keep the same unit, or you can, if you are getting confused with this, you can convert all this centimeter into meter and solve the problem. But later, when they ask, if they ask in the problem that discharge should be in terms of meter cube per second or centimeter cube per second, or in liters per second, then you have to change that. Fine. So now next. D1 equal to 20 centimeter. Area is how much for this? This diameter 20 centimeter and throat centimeter. So we have got H. Okay, don't worry. Next is you have to calculate D1. A1, sorry. What is A1?
314.15, sir.
314.15 centimeter square. D2 is 10 centimeter. What is E2?
78.53
17.53 centimeter square. Okay.
centimeters square.
Okay. Then CD is 0.98. So which formula we are going to use here? What we have to find out? Discharge, right? We have to find the discharge. Which formula we are going to use? The same formula. Q equal to CD A1 E2 A1 square minus E2 square divided into square root of 2GH. H we have found out. It is 400 centimeter of oil. See, one thing is there. Okay. We want to find out Q. CD is 0.98. Listen carefully. CD is 0.98. Area is A1 is 314.16 into 78.54 divided by square root of 314.16 square minus 78.54 square into square root of 2 into what will be this G? What will be G?
9
9? What will be the G value? What will be G value?
9.81.
But it 9.81. You are saying 9.81. Okay, 9.81 is the value. What is the unit for this now? G. Meter per second square. Right? Meter per second square is the unit, right? Acceleration due to gravity. Meter per second square. But I have taken everything in terms of centimeter, na? I have taken in terms of centimeter or no? Then you cannot take 9.81. You have to convert that 9.81 into meter into centimeter. Convert it. Convert that 9.81 into centimeter per second square. How much is the value? It will be 981 centimeter square per second, right? 981 centimeter per second square, sorry. 981. Substitute the G value as 981. Then you solve. Don't get confused. That's why I'm telling you. Tell me the answer fast for Q. Because I have to solve one more problem. What's the answer? Fast.
Seven zero four double 2.40.
Unit centimeter cube per second, because everything is in terms of centimeter cube. 704 point. I have got 70465 centimeter cube per second. If we convert it into liter per second, it will be 70.465 liter per second. So this is the answer which I have got. Okay, fine. The next problem is, find the discharge of a water flowing through a pipe of 30 centimeter diameter placed in an inclined position where a Venturi meter is inserted to a pipe, okay, having a throat diameter of 15 centimeter. A pipe is there which is placed inclined, okay, and I am placing a Venturi meter to it, which is having a throat diameter of 15 centimeter, okay. The difference of pressure head, the difference of pressure head between the main and the throat is measured by a liquid of specific gravity zero point
Sir,
0.6.
last answer. Sir, last problem answer, sir.
You can check.
Okay, sir. Yes, sir. Okay, sir. Continue, sir.
So there's a pipe of 30 centimeter diameter. There's a throat. We are connecting a Venturimeter which is having a throat diameter of 15 centimeter. The difference of pressure head between the main throat and the pipe of a liquid of specific gravity is 0.6, which is having an inverted U2 manometer which gives a rating of 30 centimeters. This is X. The loss of head between the main and the throat is 0.2 times that of the kinetic head of the pipe. Okay. So the question is that there is a pipe which is through which the liquid water is flowing, okay, and the pipe diameter is 30 centimeter, and we are connecting a Venturimeter which is having a throat diameter of 15 centimeter. 15 centimeter. Okay. The difference of pressure between the main and the throat is measured by a liquid of specific gravity 0.6 in an inverted U2 manometer. So, can anyone tell me what is the change we are seeing here? We are seeing that there is a differential manometer which is connected to this, right? Inverted differential manometer, inverted U2 manometer. I've told you that in an inverted U2 manometer, a liquid which is there in the manometer will be lighter compared to the liquid which is flowing through the pipe. I have told you last time also. In an inverted U2 manometer, a liquid which is there in the U2 manometer or whatever manometer is there, it will be lighter compared to the liquid which is flowing through the pipe. Okay, so here the same thing is there here. A liquid which is there in the manometer is having a specific gravity of 0.6, and the liquid which is flowing through the pipe is having a liquid force of diameter like sorry, the specific gravity as 1, sorry, 1000, 1, because The water which is flowing through the liquid which is flowing through the pipe is water, whose specific gravity is 1. And in liquids we are having a differential manometer as this one. Therefore the values will be like this. Okay, next, so we have drawn this. This is a inclined Venturi meter. This is the inclined Venturimeter which is placed. Okay, and it is having a distance of, this is the liquid specific gravity which is there in the manometer. The water is flowing through the pipe. Okay, and the difference in the manometer is x, that is 30 centimeter. Okay, so this is the diagram. Now what is the given thing? Diameter at inlet d1 equal to 30 centimeter. So what is the diameter? What is the area? Anyone? What will be the area?
Seven 706.85.
706.85. Okay, what is area? Diameter of throat d2 15 centimeter. What will be the area?
176.71.
7.7 centimeters square.
176.7 centimeters square. Good. Now what is given next? The difference in specific gravity is given, that is 0.6, and the reading of differential manometer x equal to 30 centimeter. Now how you gonna approach? How you gonna calculate h now? How you gonna calculate h? Which equation you are going to use? H equal to x bracket 1 minus SL by S naught. I hope so it's right. So the difference of pressure head. So we are going to use H value as x equal to 1 minus SL by S naught. We have seen it in the previous slides. You might have observed. Okay, whenever the fluid is lighter in the manometer and heavier in the pipe, we are going to use that equation. Fine. What is the answer for this? H equal to x. Where SL, what is the H value of H here? What is the value of H? What is the value of H? You have x as 25 centimeter, sorry, 30 centimeter into 1 minus 0.6 divided by 1.
Well,
How much?
12.
12 centimeter of water. Okay. Previously it was 12 centimeter of oil because oil was flowing through the pipe. Here the water is flowing through the pipe. Now you have got H value. Now what you have to determine? You have to find out the discharge through the pipe. But while flowing the discharge through the pipe, you have to measure the kinetic head of the pipe. What is given here? There is a loss of head. HL is given by 0.2 times of the kinetic head of the pipe. So this is HL. Don't get confused with this HL and this H. This is the loss of head because of the kinetic energy of the fluid which is flowing through the pipe. So kinetic head of the pipe is given, not throat. If it was throat, it will be V2 square by 2G. But it is given as kinetic head of the pipe. So applying the Bernoulli's equation at this point, we are getting P1 by rho G minus plus Z1 V1 square by 2G and everything. Okay, this is the expression, and HL is what? The loss of head. Now, or we can write like P1 by rho G plus Z1 minus P2 by rho G plus Z2 plus V1 square by 2G minus V2 square by 2G equal to HL. Now substitute the value of HL as 0.2 into V1 square by 2G. This you can substitute as what? 12 centimeter. This total you can substitute as 12 centimeter. Okay, like this. So as P1 by rho G plus Z1 minus P2 by rho G plus Z2 equal to H equal to 12 centimeter of water. HL equal to 0.2 into V1 square by 2G. These are the two expressions. We have to substitute in that. So what will be there? As I have told you, this P1 by rho G plus Z1 minus P2 by rho G will be 12. Plus remaining what will be V1 square by 2G minus V2 square by 2G equal to 0.2 into V1 square by 2G. Now, how many things are different here? Which how many things are variable? We don't know. We don't know the value of that. We don't know the value of v1 and v2 both. Okay, so we have to get an expression where we get both as same. So we have to use continuity equation here. See here, I have substituted this and I have got this answer like this. Okay, I have changed it. So I'm using now continuity equation at section 1 and 2. So I'm using a1 v1 equal to a2 v2. Next, so which equation I have to use now? I can take any one, v1 or v2. Okay, v1 equal to a2 by a1 into v2. So I'll substitute the value of v1 as a2 by a1 into v2. So that is, we have got v2 by 4, because whatever area I have got, I have divided and multiplied it by v2. Okay, fine. So now substituting the value of v1 in this equation 1, substituting. So after substituting, we have got the answer. Can anyone calculate me the value of v2? Calculate the value of v2. Calculate the value of v2. You don't require any other values from here. You can easily calculate it. What is the value of v2? Anyone? So the value of v2 which I have got is 157.4 centimeter per second. How to calculate discharge now? How to calculate discharge? Anyone?
Area into value.
Area into velocity. Okay, calculate and let me know the answer. So what are things you require here? Q equal to area into velocity. How much is area and how much is velocity? What is the answer for discharge? Area, you know how much it is? I've seen in the previous problem. Area is 176.7 into what?
27814.
into 157.4. So that is 27804 centimeter cube per 800 centimeter cube per second. Okay, if we convert that into liters per second, it is 27.8 liters per second. Okay, these are the problems which we have solved from Venturi Meter. Okay, and these are important problems. Whichever I have solved, they are from the question papers. So these are the 5 problems which I have solved from the Venturi Meter. So in the next class, we will be dealing with the orifice meter. Okay.